More examples. Now we are going to see center of gravity of solids. So solids include a cone, and look at the shape of the cone. If I put it horizontal, as you see, this is going to be my height from the base up to this is what we call the vertex. The center of gravity is from here up to here. So we can locate it either from the base or from the vertex. So from the base, the horizontal is going to be just a quarter of the height. If you look at it from the vertex, then this one is going to be 3/4 of the height. Then you see from here up here, it's just going to be the y coordinate, as simple as that. Where V is the vertex, H is the height, and the R is the radius. Now, when we come to, so either you get it from the base or from the vertex, all of them are okay, no problem. So either from here you can reach the center of gravity, or from this side to this side you can reach. So even the triangle, you can locate either from the vertex or from the base. It's okay. Those answers both are going to be right, but we always want one. Then the solid of the sphere is going to be, if this is the D, we said always, the center of gravity is on the line of symmetry of a solid, out of a body. So here you see now, this one you see, this line of symmetry divides this line of symmetry divides the object into two. That's why even here, you see when you follow this cone, if you divide it into two parts, you see this is the line of symmetry. So always the center of gravity is on the line of symmetry. Told that in previous lessons. Then here it's going to be 3/8 of the radius, then R from AB, from this line or from the center. Then you can calculate also from this side, it will be 5/8 R, the x coordinates. Then the cylinder, of course, now I'm putting it horizontally. This is the radius, from here up here is the height. It's going to be a quarter of the, I know this one is supposed to be, let me, for you. So this is a half. So for it, it is a half, it sits in the middle. This one is symmetric about that, so it's in the middle. So this is a half H over R from the base. Either from this side or from this side, it's going to be a half, because for it is going to act in the middle, because this is well balanced. Okay, let us see now composite bodies. These are usually made up of two or more bodies joined together to form one body. To find the center of gravity of these bodies, draw any line of symmetry if they are there, and of course know that always the center of gravity is on that line of symmetry. Choose two axes. Line of symmetry divides that. Now, like you see this is the line of symmetry because it divides this into two parts, as we've been seeing. So whenever an object has line of symmetry, so it's always better to do that. Then choose the axes which are perpendicular to each other. These ones now, if there is not symmetry, I mean you can trace a line of symmetry. Even if you can trace, you can choose now two sides which you are going to base on to get the x coordinate and then the y coordinate. But these two sides you are picking, they should be perpendicular to each other or at right angles to each other. This is what it means. You either pick this and this because they are perpendicular to each other. Okay? So that's the idea. So you choose those two axes as long as they are perpendicular to each other. Divide the body into two standard bodies. Now, if you join say triangle and then a rectangle, you can divide that into two bodies. Standard bodies means you can able see that this is a triangle, you can able see that this is a rectangle, this is a square, and so on. Note, in uniform laminar, mass stock weight is proportional to the area, and in uniform solids, mass stock weight is proportional to the volume, not area. Volume. The volume, not area. Okay. What happens there now? If you want to get our mass, you get the area. You know this is the proportional side. So to remove the constant, this way you get the mass per unit area. What you get to get it, if they give you a ball like this, and then they tell you to get the mass, you get the area of this body, then times the mass per unit area. If you know the mass per unit area, you can let it be m, and so on. If you want the weight, the same case, first get the area of this body, then calculate times the weight per unit, the weight per unit area. So you can say let it be W, as simple as that. So in most cases, it's better always to use the weight, because when you use the mass, remember to get weight, you have to multiply by the D to convert to weight. So it's always use the weight, simplify it so that you don't forget the D. Okay, let's see some examples. Now these ones are going to help us in the next examples. I'm using them so that they prepare you in the next examples, the next lesson. Find the center of gravity of the following lamina. A, they give you this. We said for a triangle. Now we say if you divide this into 2, of course you are going to be having this as our median. This one here. So you see, if you divide this and you hold our B, is going to be in the middle there. So we said from here to here is our height, which is 9. And we said from the base, this is from the base, we said it's a third of the height, and from the vertex is 2/3 of the height. So if I get 2/3 and a third, I will get that. So always from the base, if you want the length from the base, you get a third times the height you have. Or if you want the length from the vertex to the center of gravity, you get the height, multiply it with the 2. So anyway you define it, it is okay. But you have to put from where. Okay? So now, let me get it from the base. Of course, this one is, you see that this one is divided into 2. And you see that it's always at that line of symmetry. So from here to here there are 6, meaning my center of gravity is going to be x bar, y bar. So my D is going to be, now the x coordinate from here to here, you see, is going to divide this into 2. So I'm going to be adding 6 over 2. Then y, let me say from the base, it's going to be a third h, which is going to be D3, 9 over 3. And so my D is going to be 3 over 3. As simple as that. From the, because I used this, so I say from the base. Another can get it as, another can get it, or you can get your B as 3, then 2 over 3h. Now here, I'm using this from the vertex B, which is going to be, D into this is 3. And when you multiply 2 over 3 times the height, which is 9, you can say this is D, 3, 6. From where? From vertex. So either way, your answer will be okay. Now I'm saying from the vertex because I'm using this one from the vertex. Simple. Of course, this one is going to be the same. A half of this. Okay, now let us get the center of gravity for this. This one, these are very easy. You start our line of symmetry is going to be here. We should divide that into 2 and also to divide this into 2. What does it mean? It means that our center of gravity is going to be located there. So half of this. So our B, x bar, y bar is going to be a half of 12. Also from here to here, half of it, because it's now these ones we are now adding for the lamina. There is no mass attached to here. We're just using the length and the width. So this one, then from here to here, so it's going to be 8 over 2. So my D is going to be 6, 4 with ease. When I come to this, these are these sides, they are telling that they are equal. So what does it imply? That this is a square. When the square also has 2 lines, has a line of symmetry vertical and also line of symmetry there. It has more than one line of symmetry. But now, if I use these 2, it means that now my center of gravity is going to be located there. So meaning my D, x bar, y bar is going to be the D then because the sign is the same as that. So 5 over 2, comma, 5 over 2. So my bit here is going to be 2.5, comma, 2.5. Now, these ideas are going to help us in the next lesson. So see you in the next lesson. That's it for now. See you there.